All right, today we're going to talk about 1.3 equations. And I know you guys have already solved equations before back in 7th grade and 8th grade and probably a little bit before. But we're going to talk about a little bit of notation that you may have not seen before. Okay. An equation is formed by placing an equal sign between two numerical or variable expressions. So that could just be like 3 plus 2 equals 3 plus 1 plus 1. Okay, and that is a numerical with an equal sign in the middle, okay, or you can have variables also. Okay, the open sentence equation is when it actually does contain those variables. The domain of a variable is the given set of numbers that the variable may represent. So you could either write it as x equals 1, 2, 3, 4, or x is the element of 1, 2, 3, and 4. Or belongs to the set of members 1, 2, 3, and 4. Okay. The solution or the root is any value of the variable that turns an open sentence into a true statement. So if I look at this 5x minus 1 equals 9, the solution or the root is what x would make that left side equal to the right side. The solution set would be the set of all solutions of an open sentence. Okay, so you might have more than one depending on what it's asking. Okay. All right, so let's look at example 1 here. The domain of x is 1, 2, 3, and 4. So is the equation of 5x minus 1 equal to 9 true when x is 1, x is 2, and x is 3? Okay, so we're not actually solving for x in this sense. We are using that evaluating that we talked about before. And we're going to evaluate when x is 1, when x is 2, and when x is 3, and see if that left side equals the right side. Okay, so we're going to look at when x equals 1. So plugging in 5x represents 5 times x minus 1. Does that equal 9? Okay, so let's plug in that 1. So follow order of operation on the left-hand side here. So 5 times 1 is 5. 5 minus 1 is 4. Does 4 equal 9? No. So when x is 1, that is not a solution. So x equal 1 is not a solution. Okay. All right, let's look at when x is 2. When x is 2. So if I take 5 times x, which we're going to replace with 2, minus 1, does that equal 9? So follow orders of operation. So 5 times 2 is 10. 10 minus 1 is 9. Does 9 equal 9? Yes, it does. So 2 is the solution of 5x minus 1 equals 9. Okay. And then let's go ahead and check 3, which in an equation we should only have one answer. But we're going to keep going and try. X equals 3 in this case. So 5 times 3 minus 1, does that equal 9? So 5 times 3 is 15. 15 minus 1 is 14. Does 14 equal 9? No, it does not. Okay, so 3 is not a solution. Okay. So our solution where it's true is x equaling 2. All right, so now this one for number 2 here is a little bit different because it says now solve y times the quantity of 4 minus y equals 3 if y is the element or y belongs to the set of 0, 1, 2, 3, and 4. It's just a different way to write it, but we're still looking at when y equals 0. Does the left side equal the right side? When y equals 1, when y equals 2, and when y equals 3. So let's go ahead. So y is 0, so we're going to plug in 0 for y. 4 minus y, which is 0 again. Does that equal 3? Okay. Well, orders of operations say we do this parenthesis first. So 4 minus 0 is 4. And then we multiply 0 times 4 is 0. Does 0 equal 3? No. So 0 is not a solution. Okay. Let's look at the next one. When y is 1. So y is 1 times 4 minus 1, because y is 1, does that equal 3? So 4 minus 1 is 3. 1 times 3 is 3. Does 3 equal 3? Yes, it is. So 1 is a solution. Okay. Let's look at 2. So y is 2 times the quantity of 4 minus y. Does that equal 3? So let's plug in our 2. So parenthesis first. 4 minus 2 is 2. 2 times 2 is 4. Does 4 equal 3? No, it doesn't. So 2 is not a solution. So 0 isn't and 2 isn't. And let's try 3 now. All right, so y is 3 times 4 minus y. Does that equal 3? So let's plug that in. So we have 3 on the outside. Parenthesis first, 4 minus 3 is 1. 3 times 1 is 3. So does 3 equal 3? Yes, it does. So guess what? Y equals 3 is another solution. Okay. So we can say this a couple ways. These solutions are 1 and 3. Therefore, the solution set is 1, 3. So these dots here in the triangular means therefore. Therefore. Okay. All right, let's go ahead and look at our last example here. Okay, solve over the domain. So again, it says solve over the domain. So the domain is our x, right? Our variable. So x equals 6, x equals 8, and x equals 12. 5 more than twice a number is 29. So let's write this algebraic expression. So 5 more than. So 5 more than means addition. Twice a number would be 2 times our variable, which I've been using x, is our equal sign 29. So there's our equation. Now we're going to plug in 6, 8, and 12 and see what our solution set is. Okay. So let's look at 6. So 5 plus 2 times 6, does that equal 29? So let's do multiplication first. 2 times 6 is 12. 5 plus 12 is 17. Does 17 equal 29? Nope. So 6 is not our solution. Okay, let's check 8. 5 times 2 times the quantity of x, does that equal 29? We're going to place 8 in for x. So let's do our multiplication first. 2 times 8 is 16. 5 plus 16 is 21. Does 21 equal 29? Nope. So 8 is not a solution. Okay. And now let's go ahead and try 12. 5 plus 2 times x, does that equal 29? And my x is 12. Okay, so let's do our multiplication first. So 2 times 12 is 24. 5 plus 24 is 29. Does 29 equal 29? Yes, it does. So therefore, my solution set is 12. There you go. Okay. All right, if you have any questions on this, please let me know.